Ladies and gentlemen, we are making a video to help you guys understand transformations, right? On this section 9.3, we learned about vertex form. We learned that the vertex is the hk value. You think opposite on h, you take k for what it is. We already know how the a value works because we've been dealing with that a value since the beginning. Let me actually take a moment right now and let's talk about the parent graph y equals x squared. So here we go. The parent graph y equals x squared is a regular U-shaped curve. Now, what if I did not have a regular y equals x squared? What if it was y equals negative x squared? If the a value changed to a negative, all that would do is cause the parabola to reflect and open down, okay? Regular y equals x squared, the a value is 1. What if your a value became negative? It reflects over the x-axis. It reflects over the x-axis. It opens down instead of up. So the first thing that we're going to have to understand this section is that if your a value is negative, it opens down. If your a value is positive, it opens up. We already knew that, but let's describe it as a reflection over the x-axis. Today we're going to be describing changes in parabolas. So from your parent graph y equals x squared, if you change the a value to a negative and make it y equals negative x squared, all that does is causes a reflection over the x-axis, right? Here's your x-axis. It reflects over the x-axis, which causes it to open down, okay? Let's also talk about the different a values and how it affects the parent graph parabola. Here's your parent graph parabola, y equals x squared. And if I were to change the y equals x squared to a fraction that's closer to 0, like y equals 1/2 x squared, you know what would happen? It would get vertically compressed. I know that that sounds weird that I'm saying vertically compressed. I normally say wider. That makes total sense, right? Here's y equals x squared. If I change it to a y equals 1/2 x squared, it gets wider. But we're going to be using the keywords today, vertically compressed and vertically stretched. Now let's think about that. Vertically is up and down. So if you take something and you vertically compress it, it's gonna, imagine a parabola and you vertically compress it, it's gonna get wider, it's gonna get smashed, it's gonna get wider, okay? So if your a value is 1, it's a regular U-shaped curve, but if you change that a value to a 1/2, it gets wider, which today we're gonna call a vertical compression. Any fraction that's less than 1, it's getting compressed. Any number that's greater than 1, here's your regular y equals x squared. Your a value is 1. It's a regular U-shaped curve with the pattern 1, 1, 2, 4, 3, 9. What if I changed it from a y equals x squared to a y equals 2x squared? Then that new a value of 2 is greater than 1, and that causes it to stretch, okay? So before we would say it gets narrower, which it does, but we want to use the vocab words that we're going to be learning in a couple of moments, which is a vertical stretch. Okay, so if your a value is a fraction less than 1, it gets compressed, it gets wider. Here's a regular a value of 1, y equals x squared. If your a value changes to a value greater than 1, like y equals 3x squared, it's going to stretch. So instead of saying it gets narrower or it gets wider, which is totally fine, that's what is actually happening, we're going to use the words vertically stretched, which means narrower, or vertically compressed, which means wider. So I hope that helped a little. Let's move on to the actual second page of these notes. Transformations, okay? So what is a transformation? How about the transformers? What are they? They're robots that change into cars or planes that change into robots, right? It's change. So a transformation is really, especially in parabolas, it's really how the parent graph, the easiest type of graph, y equals x squared. This is a picture from the very first graph that we did, y equals x squared. This is what we call a parent graph. This is where we got the pattern 1, 1, 2, 4, 3, 9. And all other parabolas, it doesn't matter if it's in standard form or vertex form, all other parabolas are really simply transformations from your original to a new parabola, okay? In other words, maybe it gets reflected over the x-axis. Maybe the vertex is not at 0, 0. Maybe it's at 5, 2, which means that the parabola got shifted 5 units to the right and 2 units up. Maybe it's wider, which means that you'd have to have an a value that's a fraction, less than 1, right? Or maybe it's narrower, right? Which means that the a value would have to be a value greater than 1 for it to be a vertical stretch. So transformations are changes that happen from this original beautiful regular U-shaped curve that has the vertex 0, 0 to whatever new parabola you have. And we need to actually write down in sentences what those transformations are, okay? So let's look at the actual notes. What is a transformation? It's a change in the position, size, or shape of a figure. And there are these 3 different types of transformations that are possible in parabolas, okay? We're going to begin with analyzing and seeing if there's a reflection. How do we know if the parabola opens down instead of up? If the a value is negative. So if you do see that your graph has a negative a value, then you will state that the a value, you will state that it gets reflected over the x-axis. If you don't have a negative a value, then you don't have to worry about stating anything about reflections because there is no reflections. So first, check and see if your a value is negative. If it is, you're going to say it gets reflected over the x-axis. Next thing to look for is, does the a value make it wider or narrower? But in today's vocab words, we're using, does it get vertically stretched? Vertically stretched or vertically compressed? Remember, a stretch means that it's narrower. A compression means that it's wider. So if your a value is greater than 1, then it gets vertically stretched, which means narrower, right? If your a value is less than 1, it gets vertically compressed, which means wider, okay? So all of these notes are written for you. And now for the final transformation that we could describe, it's called a translation, or you could use the word shift. Okay, so how does your parabola shift? Does it move left? Does it move right? That depends on the h value. Does it move up or does it move down? That depends on the k value, right? And so let's take a look at, and once again, to describe transformations, you're going to have to go through these 3 questions, right? Question number 1, does it get reflected over the x-axis? In other words, is your a value negative? If the a value is negative, you're going to write down as your first sentence, it gets reflected over the x-axis. If you don't have a negative a value, then you go to this next question. It says, does it get vertically stretched or compressed? Well, that depends if your a value is other than 1, right? If you have an a value of 2, you would say it gets vertically stretched by 2. If you have a fraction like 1/2, then you would say it gets vertically compressed by 1/2, okay? So that's the second thing you state. The third and final thing you state is, does it move left or right, depending on your h value, but of course think opposite of what you see. And does it get shifted up or down according to your k value, which you take for what it is. So I know that this could be overwhelming, but let's take a look at this first example that has the answer there for you. Now, this is what you're going to see on a quiz. Look, you're not going to see that right there. This is what you're going to see. Here's a question. Describe the changes from your original f of x function to your new g of x function, where your original f of x function is your parent graph, y equals x squared. And we should all know what y equals x squared looks like. It's the beautiful regular U-shaped curve that has the vertex 0, 0, that has a pattern 1, 1, 2, 4, 3, 9. It's not wide, it's not narrow, it's a regular U-shaped curve, vertex 0, 0. And you got to describe how it changes from here to this new graph, -2, parentheses x minus 4 squared minus 6. So let's describe the transformations according to the questions that were listed above. Question number 1, does it get reflected over the x-axis? What do you guys think? Does this get reflected over the x-axis? There's a negative right there, which means yes, it gets reflected over the x-axis. That would be the very first thing that you write down. Number 1, it gets reflected over the x-axis. You actually have to type this in, write it out in words. Number 1, it gets reflected over the x-axis. That's another way of saying that it opens down because the a value is negative, okay? So after that, we got to ask ourselves, does this parabola get vertically stretched or does it get vertically compressed? Or maybe it doesn't at all. But because the a value is 2 instead of 1, that means that it gets vertically stretched by 2. And that's the second sentence that you need to write down. It gets vertically stretched by 2. You could put by a factor of 2, or you could just put by 2. It doesn't matter to me. You could just write down it gets vertically stretched by 2. You don't have to write by a factor of. And now for the final description of the changes is your h and your k. Your h, you got to think opposite of what you see here, and the k, you take it for what it is. So the h is really your shift left or right. Technically, it's the x value of your vertex. So that would mean that h is positive 4, which means you're going to move it 4 units to the right. Okay, that's the description of the change. And the k value is negative 6, which means that you're going to be moving it 6 units down. So your final description of the changes that are happening here, check it out. The third thing you're going to be writing is it gets shifted 4 units to the right. Why to the right? Because h equals positive 4. You think opposite of what you see there. And 6 units down. Why 6 units down? Because your k value is negative 6. Again, this might seem overwhelming because it's the first time you're seeing it, but the more you practice, the easier it gets. And it really is, I mean, that's your answer right there. Those are the 3 sentences that you would need to write down in order to describe how it changes from the original parent graph to this new graph g of x. Maybe I could actually draw or show you what changes actually happened. So when we take a look at a regular U-shaped curve, the parent graph y equals x squared, that has a vertex 0, 0, 1, 1, 2, 4, 3, 9, reflected to the other side. It's a regular parabola that opens up with a vertex 0, 0. So let's check out the a value is negative, which means that it opens down instead of up. So the first transformation that you see is that this parabola gets reflected over the x-axis. So it opened down instead of up, right? That's the negative sign. Okay, so I'm just showing from the original parent graph to this new final graph. It first gets reflected over the x-axis. After that, the a value is 2, which causes a vertical stretch. So because of this 2 right here, that blue graph that's opening down is now going to get stretched. So it's going to get narrower. Okay, it got narrower. And then now for your final transformations, you're going to move 4 to the right and 6 down. So this original vertex on the green narrower graph, it's going to go 4 to the left, 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6 down, right? So you're going to have your new dot over here, and it's still going to be that same exact narrow parabola, but opening down over there. So the skill that we're trying to build here, ladies and gentlemen, is understanding the original parent graph and then looking at these different values, the a, the h, and the k, and being able to understand what happens to the original and how you end up. I mean, imagine that, guys. You're going to be able to look at an equation on a multiple choice test, and you're going to be able to see that it's the one that has a vertex at 4, negative 6, and that's a little bit narrower, that's opening down. You're going to be able to identify the correct graph without doing any math, right? Of course, if you wanted to be precise, yeah, you would have to have an actual XY plane. You would actually have to use the pattern 1, 1, 2, 4, 3, 9, or modify that pattern according to your new a value of 2. But with this knowledge, you'll be able to identify the actual parabola that belongs to the equations. It's pretty crazy. Let's move on down here, and let's practice describing some of these transformations. And we're going to be describing the transformations always from the original parent graph of y equals x squared to the new graph that's given to you below, okay? So let's go through and ask ourselves the questions. The question number 1 that you should ask is, does it get reflected over the x-axis? Well, let's take a look at our A value. Our A value is what tells us if it gets reflected or if it doesn't get reflected. It also tells us if it gets vertically stretched or compressed, or if we don't mess with it because it doesn't get wider or narrower, it stays the same. So does this get reflected over the x-axis? The answer is no. Why not? Because the A value is not negative. The A value is +1. Okay? So it did not get reflected over the x-axis. We don't write that down. We just ignore it. Or not ignore it, but you just move on to the next question. Does this get vertically stretched or compressed, or does it just stay the same? The A value is 1. Does it get wider or narrower than the original parent graph? The question is, or the answer is, it stays the same. The A value of 1 provides that same pattern 1, 1, 2, 4, 3, 9. It's not going to get wider. It's not going to get narrower. So let's get this straight, guys. It did not reflect. It did not get vertically compressed or vertically stretched. It stays just as wide as the original parent graph. But there is a change that I have to do. The change is my H and my K. Obviously, my vertex is -3, -5. So it didn't get wider, it didn't get narrower, it didn't reflect over the x-axis. It still opens up, but the only change is that it got shifted 3 to the left and 5 down. That's the description we need to write. The only transformation is that it gets shifted or shifts 3 to the left and 5 down. That is it. All right? Now, I hope we appreciate this. I mean, imagine if I gave you this equation and I gave you 4 multiple choice parabolas, you should be able to conclude, well, the A value is 1. That means that the original parent graph did not get reflected. It still opens up. The A value is 1. It didn't get wider. It didn't get narrower. It's still the regular U-shaped curve, but it does shift 3 to the left because you have to think opposite of what you see here. So it does shift. This vertex goes 1, 2, 3 to the left and 1, 2, 3, 4, 5 down here. It's the same exact parabola. It does not get wider. It does not get narrower. It still opens up because that's what the A value tells us. So it only gets shifted 3 to the left and 5 down. So you should be able to identify which is your correct parabola if you understand these different transformations. And of course, the transformations always come, you always look at the A value first. If it's negative, you have to say that it gets reflected over the x-axis, that it opens down. If the A value is greater than 1, you would say it gets vertically stretched by whatever that number is. That just means that it gets narrower. If it's a fraction less than 1, then you'd say it gets vertically compressed by whatever that fraction is, which means that it gets wider. So this one was pretty easy. It just shifts 3 to the left and 5 down. It did not get wider. It did not get narrower. It didn't get reflected over the x-axis, causing it to open down. Let's move on to another one. So again, what we're doing is going from the original y equals x squared, that original parabola that has a vertex at 0, 0, and it's not too wide, it's not too narrow, it has a regular pattern 1, 1, 2, 4, 3, 9. What kind of changes does this original red parabola, the parent graph, what kind of changes does it go through to get to this new graph? Okay, well, what does this change actually tell you? Anybody? What does this negative sign tell you? Thank you, Alondra. It's going to open down. That's correct. The negative A value tells you that it's going to open down. Now, the words that we want to use in today's section is the description that it gets reflected, or it reflects over x-axis. Okay? So if I think about that the negative sign causes this original parent graph to reflect over the x-axis, I would now be at that blue parabola right there. It just reflects over the x-axis, which technically means that it opens down. That's absolutely right. But the words we want to use in this section is that it gets reflected over the x-axis, or it reflects over the x-axis. That is the first thing that we describe, because that's the first thing we see right here. It's negative. Okay, so it reflects over the x-axis. Next thing is that the a value is 2. I mean, yeah, it's negative 2, but we already dealt with the negative. We said it reflects over the x-axis. What does this 2 actually do? Does it cause a compression to make it wider or a stretch to make it narrower? What does it do? The a value of 2 causes a stretch. So you would say it gets vertically stretched by 2. You're going to have to write it out. We're not doing math in this section, guys. We're describing with words the changes that happen from the original parent graph to our new final graph. So let me actually show you the difference of it being stretched by 2. Okay, so far we had the original parent graph up here. It got reflected over the x-axis, so now it's opening down. That's a negative sign. The a value of 2 is going to cause a stretch, a vertical stretch by 2, which means that it's going to get narrower. It's going to get narrower. Okay, so we now have a narrow green graph that's opening down, but it's still at the vertex 0, 0. We need to describe the final change to get to our new vertex HK. So what is our final change? Well, you have to think opposite of what you see here, and the k value, take it for what it is, and there is no k value. So you would describe your third and final description of the change from the original parent graph to this final graph is that it shifts how many units? It shifts 3 units. Where? To the left or to the right? Remember, you got to think opposite, which means that your h value is really positive 3, and positive on the x is to the right. So shifts 3 units to the right. And if you had a k value, like a plus 7, you would say, and it shifts 7 units up. Or if you had a minus 7, you would say, and it shifts 7 units down. But there is no k value. The k value is 0, so you don't have to mention it shifting up or down. So for my final transformation on this green graph, it's going to move 3 units to the right. So I would have to go 1, 2, 3 over here, and it would still be a pretty narrow parabola like the green one was. But now I know what the parabola looks like just by analyzing the a value, the h value, and the k value. Okay. Again, the goal for today is to be able to think of the original parent graph that has a vertex 0, 0, that has a regular U-shaped curve opening up with the pattern 1, 1, 2, 4, 3, 9. That's y equals x squared. Thinking, how does it change? And in the correct order of how it changes, the negative is reflects over the x-axis. The a value of 2 is a vertical stretch by 2. And the h and the k are your shifts, which are also known as translations. But I think the word shift is easier to remember. It just shifts 3 units to the right, and it does not go up or down. It's just 3 units to the right. Let's try another. Now, this one, you could force it to look like vertex form. In vertex form, you want parentheses around your x with the square on the outside. That way you could see what your h value is and what your k value is. But more importantly, let's begin with that first question. Is this a value positive or negative? The a value is obviously positive. So do I have to write down that this parabola gets reflected over the x-axis? The answer is no. I don't have to write that down because there is no negative sign. If there was a negative, I would have to write down that it gets reflected over the x-axis. So I don't have to write that down. But I do need to talk about this a value of 1/2. What does that a value do to the original regular U-shaped curve? What does that a value do? It causes a vertical, what do you guys think? A stretch or a compression? What do you think? Thank you for those that participated. It is a vertical compression. And if you don't know, it's pretty simple. This is a vertical compression by that fraction 1/2. Now think about this. Compression is that it's getting smashed, it gets smaller. A stretch, it gets big, it gets longer, right? Now let's think about logically. If you take any number like 20 and multiply it by 1/2, does it get bigger? No, it gets smaller, right? If your a value is a fraction that's less than 1, it's going to get smaller, it's going to get compressed. It's going to get compressed. Technically, that means that it gets wider, okay? If your a value is a value greater than 1, it's going to stretch. It's going to get bigger. 20 times 2 is 40. 20 times 3 is 60. It gets bigger. So if your a value is bigger than 1, it's going to stretch. If your a value is less than 1, it's going to compress. Okay? So that's the first thing that we wrote down as our description of our transformations. It gets vertically compressed by 1/2. After that, we need to talk about, does it shift left? Does it shift right? Does it shift up or down? And by how many units? So the second thing to describe is that it shifts where? It shifts 4 units where? To the left, to the right, up, or down? What do you guys say? That is correct, 4 units up, okay? And that's all you have to describe from the original parent graph to this one. Now, I don't know, I might as well accompany the visuals here. Here's your regular XY plane, your regular parabola that opens up, has a pattern 1, 1, 2, 4, 3, 9. It's just a sketch. And we noticed that it did not get reflected over the x-axis, but it did get vertically compressed by 1/2. If this would have been a 2, it would have gotten stretched, it would have gotten narrower. But it's 1/2, which means it gets smashed, it gets compressed, it gets wider. So I'm gonna make a wider graph, okay? And then 4 units up, so you're gonna take this blue graph and move it 1, 2, 3, 4 units up, and it's gonna stay exactly that wide. And there's your final graph right there. It's just a sketch, but you should be able to identify it when you're doing a multiple choice test. Let's move on. One more here. This one has all the transformations, okay? What is the very first thing that you see a negative sign? What does that mean? That means that your first transformation is the description what? Anybody? That is correct. You reflect it, right? It reflects. So the first thing we describe is it reflects over x-axis, okay? So the parabola that used to open up now opens down because of that negative sign. Next thing to describe is the actual a value itself. We already dealt with the negative, so you don't have to deal with that anymore. You already said that it opens down by saying that it reflects over the x-axis. But what about the a value of 1/2? That means something. That means that it gets vertically compressed by 1/2. Again, if this would have been a 5, it would have been a vertical stretch. If it would have been a 3, a vertical stretch. But it's a fraction less than 1 that's going to cause it to vertically compress. That means that your regular U-shaped curve is going to get wider because your a value is 1/2. It gets vertically compressed. And moving on to your h and k shifts. The h value is, think opposite, h value is -1. The k value is, take that for what it is, -3. Now remember, the h value is the x value of your vertex. And when we talk about x's, we're talking about a left or right shift. So -1 is actually 1 unit to the left. And when you say -3 on k, that means 3 units down, because k, you take it for what it is. And that's the actual description of your final transformation. It shifts 1 unit to left and 3 units down. Ladies and gentlemen, that is the description from the original parent graph y equals x squared to the new graph y equals -1/2 parentheses x plus 1 close parentheses squared minus 3. That's the description. It's 3 things. So what we're focusing in on today is doing these, writing out these sentences that describe the changes. Now, we had a homework assignment and we've already done all these 6 graphs and describing their details, the domain, the range, the x-intercepts, the y-intercepts, the pattern used, the vertex. That was all great. If you look at the second page of this PDF, you're going to see this homework assignment, which is based on transformations. Now, all of the notes that we just went over are written again right here. Does it get reflected over the x-axis? Does it get vertically stretched or compressed? Describe if it shifts left, right, up, or down. right? It also has examples right here from x squared, from y equals x squared to this new function, negative 2 parentheses. So the negative sign means that it gets reflected over the x-axis. The 2 means that it gets vertically stretched by 2. It gets vertically stretched by 2. The minus 4 means that you're going to shift it 4 to the right, because think opposite, that's plus 4. So it gets shifted 4 to the right, and then minus 6, 6 units down. So the examples are there for you, the notes are there for you, and this is the homework that you guys need to practice describing the transformations of all of these questions. I know that the numbering is all messed up, but we'll work on, let's actually work on this. Try to do it tonight, describing the transformations, and we're going to pick up right here tomorrow.